In this video, I'm going to go through the first 28 multiple choice questions of sample test number 2. This is the part that has no calculator. Okay, so the first question, I have two functions, g of x, h of x, in the xy plane. What is the point of intersection? So the point of intersection happens when, for the x value, that the function values are equal to each other. So we're basically solving the equation 4 to the x equals 16 to the x plus 2. Now we don't need logs for this because we can write 16 as 4 squared, and then we can use the rule that you multiply exponents together when you're raising a power to a power. And now they're both 4 to a power, so I can just set the two exponents equal to each other and solve. Get -4, which we hope is an answer, and it is. Answer to the first question is choice A. Question 2. Log base 2 of x. Which number causes a value of 4 to come out of the function? So we're talking about 4 equals log base 2 of x. Now you can rearrange any equation that's like log base b of a equals c. You can rearrange to b to the c equals a. So this would be 2 to the 4th equals x, or 16 equals x, which is the answer to the second question. Okay, question 3. Function k is given by k of theta equals 2 sine theta. What are all the values where k of theta equals -1? So it's -1 equals 2 sine theta. Divide both sides by 2. -1/2 equals sine theta. Now, I like to picture a graph like that, and here's -1/2, and there's two places, there's two answers. But what are those two answers? Well, there's no calculator, but you should know that sine of 30 is 1/2, sine of 45 is radical 2 over 2, sine of 60 is radical 3 over 2. And while we're at it, in case it comes up later, and the other three values, 1 over root 3, which is the same thing as root 3 over 3, 1. So what we do is we first find what's called the reference angle, which is 30 degrees or pi over 6 radians. That's not the answer, though. Notice how they have it here. But we want the quadrant 3 and 4 answers, because sine is negative in quadrants 3 and 4. And what you do for quadrant 3, you do 180 plus the reference angle. And for quadrant 4, you do 360 minus the reference angle. So 180 plus 30 is 210, which is 7 pi over 6, because pi over 6 is like 30. And 360 minus 30 is 330, which is 11 pi over 6. That's why the answer to that one is choice D. And question 4. So there are some log rules that are good to be aware of. One of the log rules is that log base b of x to the a is equal to a log base b of x. So I would, for this log base 3 of x to the 5th, I change it to 5 log base 3 of x, which is actually the answer. Question 5. So we have this exponential function, -3 times 4 to the x power. Now, 4 to the x power looks like that, and 3 times 4 to the x power looks pretty much like that also. but when you put a negative in front, it flips it upside down. So h is always decreasing, going down. And concave down, that means it's like part of a frown, which this is. And that's why that one is choice D. Number 6. Rational function. When you have a whole, that's when there's an x, when the numerator and the denominator both become 0 when you plug 2 in. So we're looking for an x minus 2 in the numerator and the denominator, which happens for both of these, but not for these. But then there's input values of f sufficiently close to 2 correspond to values arbitrarily close to 6. Interesting. So when you put a value close to 2, this is an interesting question. You can't put 2 in to the function because you get a whole. So we're down to these two choices. But if you were to cancel out these things, and then you plug 2 in, this one you get 5 over negative 1. But this one you get 6 over 1. And that's why the answer is choice B. Basically, this is some kind of strange curve that's undefined at 2. But there's a hole, but the location of the hole is at 6. So if you plug in 2 into equation B, like as it is originally, you'll get undefined. But if you cancel out the x minus 2's and then plug 2 in, you get 6 over 1. So that means that the location of this hole is at 6. So if we get close to 2, the y value gets close to 6. Choice B. This is kind of a strange question. They're filling water into an empty container, and they see that the water first sort of fills up sort of at a slow rate, like the height goes slow, and then it starts, even though they're not putting in the water faster, they're putting water at a constant rate. But the height on so if this thing was a cylinder, like in choice A, the water would just go up, the graph would look like this. I'm putting water at a constant rate, and the height would go up at a constant rate. But what's happening is that the shape of this container, it must be kind of wider here so that it fill up at a slow rate. And then it must get narrower, and then it gets wider again. That's why I haven't seen the other two choices, but yeah, this looks like it's the answer. See, this one would fill up kind of fast, and then it would slow down, and then fast again. This one is slow, then fast, then slow. And this one, I don't even know. This one is like this. It's like slow, fast, slow, and then slow, fast, slow, something like that. So these do look kind of similar, but I still think the answer is B. Don't quote me on it. Okay, a time equals 0, the population, and then the next 10 years it's decreased by 4%. So what happens is that we have 23,144, and then every 10 years the population goes down. Oh wait, I just noticed. It's 4% per year. So every year it goes down by 4%. So basically what happens is that it starts off as this, and then the next year it gets multiplied by it gets decreased by 4%, which means, see, increasing by 4%, you multiply by 1.04, but decreasing by 4%, you multiply by 1 minus 0.04, which is the same thing as 0.9 6. So this question is going to be something like this. It's going to be times 0.96 to the t power, not minus, but times. And this is choice C. 9 is some kind of trig identity. So one of the trig identities, some of them that might be useful to know about, is that sine squared plus cosine squared equals 1, and tan squared plus 1 equals secant squared. And secant squared, or secant, is 1 over cosine. There are more, but let's just see. If I take this one and I rearrange it by subtracting 1 from both sides, I can replace the numerator with tan squared. And the denominator I can replace with 1 over cosine squared, because it was secant squared. And then if I take the numerator and multiply it by the reciprocal denominator, I get this. Now, this isn't quite a choice. Tan squared, though, can be written as sine squared over cosine squared. Then when you cancel it, you get just sine squared. So this is kind of a funny trig identity that utilized several. It used the fact that tan equals sine over cosine. It used this fact that tan squared x plus 1 equals secant squared x. And it used the fact that secant is 1 over cosine. So it used 3 of the main 8 trig identities. Number 10. Okay, the location of x in polar. So polar coordinates, I usually write it like that, basically means this 5 pi over 6 is basically 150 degrees. So in polar coordinates, you have these circles. And this is r and that's theta. So 5 pi over 6 means that I'm over here at 150 degrees. This is 0, 90, 180. So this is around 150. And the 1 is kind of which circle am I on? So we have that point. And they want to know the location of x in rectangular coordinates. So I think that's as much as I could zoom in. Let me just draw another close-up of this. So they basically want to know the coordinates of that point. There's a couple of ways to do this. One way is to know your 30, 60, 90 rules, because if this is 150, then in this right triangle, this here is 30 degrees. In a 30-degree triangle, the sides, the short side is half the hypotenuse, and the medium side is square root of 3 times the short side. But this point is over here. This is in quadrant 2. So even though this distance here is radical 3 over 2, the x-coordinate of this point is negative radical 3 over 2, and the y value is 1/2. Choice A. Number 11, exponential decay function. 2 of the points are labeled. What is the y-coordinate where x equals 0? Interesting. So every 1 unit to the left, see, it went from 5 to 10 as I go to the left. So that means at 1, it's going to be 20. It's doubling every time I go to the left by 1 unit. So it's going to be 0, 40. 12, here's a graph. And they want to know, is this linear or quadratic? You could graph it and see if it resembles. You can see the numbers are going up. But is it a line or is it like a parabola? Sneaky way to tell that is to take what are called the differences, the first differences. So it goes up by 1, and then it went up by 2. Oops, it went up by 1, then it went up by 3 actually, then it went up by 5, then it went up by 7. And if they're all the same number, it's linear. If they're not, you do it again. And if now they're all the same number, it's quadratic. So it's not linear, it's not linear, it's quadratic, and it's because the successive second differences are constant. That's saying that these are all the same number. 13. F of t is e to the t, and g of t is 7 ln t, and it's funny, they wrote it this way, which is also a fancy way of writing it like this. So f of g of t is e, that's the f function, but instead of a t here, I'm going to put the whole 7 ln t. Interesting question. So just in general, like if I say what is 2 to the log base 2 of 32? Well, log base 2 of 32 is 5, because it's asking 2 to what power equals 32. Then I go ahead and raise 2 to that power, and I get back 32. So that will be true if I say, like, what's 3 log base 3 of 97? It will be 97. Or e to the ln of 42 would be 42. So I take this e to the 7 ln t, and there's a rule of logs that you can bring the exponent up. And then I can use the fact that e to the ln of t to the 7th is just t to the 7th. And that's actually a pretty hard question. Okay, binomial theorem. So what they're asking is, what if I raise x minus 3 to the 5th power? What would be the x cubed term? So, you really don't want to multiply this whole thing out, but there's a shortcut. And the shortcut is that every term has the form like this. Okay. Now these two numbers have to add up to 5. This number actually will be 5, whatever the biggest exponent is. Now, over here, since we want to get x to the 3rd, we put a 3 here, and that would make this a 2. And this is also a 2 here. Now, 5c2, there's 2 ways to get that. One is if you know Pascal's triangle. This is 5c0, 5c1, that's 5c2. So we could just do 10 times x to the 3rd times 9, or times negative 3 squared. And as you can see, it's right there. You also might know how to calculate combinations with the combination formula. You cancel out the 3 factorials, and you cancel out the 2 with the 4. Either way, you get b for that. An interesting question. For 15, they have this function. So it's a cosine curve. Plus 1 is the midline, so this isn't it. This could be, that seems to be halfway. This is also halfway, so plus 1 only rules out choice B. For a cosine curve starts at its high points and ends at its high point, so choice D is out. That's more of a sine curve. Now I'm down to 2 things. The only thing left is, what's the period? Well, the period of this one is 4, meaning to get from high point to high point is 4 units, and this one, the period is 2. Well, the b value, what goes in front of the x, the coefficient there, is 2 pi over the period. 2 pi over 2 does equal pi. That's the answer. Whereas 2 pi over 4 is pi over 2, and that's not what's here, so the answer is choice A. 16. It is known that the relative minimum of G occurs at A, maximum. Well, we could see that. And the only points of inflection point is when it switches from frowning to smiling, is at C. At which of the following points, at which is the rate of change of G the least? Interesting. Rate of change of G. So that's like slope. So here the slope is 0. Here the slope is negative something. And here the slope is positive. So there's only 2 places where it's negative, here and here. Now, see how it's kind of frowning? When you're frowning, what's happening is that the rate of change is, the slope is getting more negative. And that's why here the slope is negative, but like a small number, and then it's a bigger negative number, which is decreasing. And then right here is where it's the most negative it's going to be, and then it starts getting less negative, until it's back to 0. And that's why your answer is actually C for that one. And that question is actually pretty confusing. Question 17. Polar coordinates. This is where you have your sort of polar graph paper. And the theta tells you how to rotate, where to rotate. And then the R value is how far you sort of go forward. So if I were to plot these 4 points, just because I was like curious, what does this thing sort of look like? At negative pi over 4, which is negative 45 degrees, which is over here somewhere, I would go 2 units. Then at negative 3 pi over 4, what is that? That's negative 135 degrees, which is 90, which is somewhere over here. That's also at 2. 5 pi over 4 is 225 degrees, which is going in this direction, actually. This is 0, 180, 225. But it says negative 2, so it's a point over here. And 7 pi over 4, it's 7 times 45, which is 315, which is actually in this direction. But it's negative, so it's back here. So it was A, B, C. Okay, which of the points lies in quadrant 2? Well, it's point D. Oh, they got a whole thing, but it's point D. Because from the positive axis, it's clockwise from the origin, so we go all the way here, but then the negative means I go in the opposite direction. The amount of water is measured by the function of G defined, okay, with T goes from... So this is basically some kind of a 25, 30, 20. So the water goes, up and down like that. It was determined that the model underestimates the amount of water used each day by 800 gallons. It's measured in hundreds of gallons. So, based on this information, which of the following is a better model? Well, if this underestimates it, we need to add 800 to this function. Well, this function, by the way, is 5 is the amplitude, because you go from 25. Oh, actually, there's the equation. They already tell us it. So we just need to add 8 to it, to the 25. that will shift the whole thing up, and then it will be all right. So the only thing that needs to change is the 25. So what's funny is that, yeah, this is the only one that's got a 33 here. So that's got to be the answer. Everything else stays the same. Two different angles are in standard position and share a terminal ray. Based on this information, which of the following gives possible values? So so here I have an angle. Let's say it's 150 degrees, which is 5 pi over 6 radians. And another angle that sort of ends up at the same place would be, there's a lot of them. For instance, 150 plus 360 is 510, which is 5 pi over 6 plus 2 pi, which is 17 pi. So there's those type of, they're called coterminal angles. But also, if you do 150 minus 360, which is minus 210, that also gets us to the same place, which is minus 7 pi over 6. So I think if you add, what would be, if you add 2 pi to one of them, you get the other one. And since all these questions have a negative and a positive answer, I'm just going to test what would happen if I add 2 pi to one. Would I get the other? Oh, they don't all have negative. Basically, they're separated by 2 pi. So that's why the answer is choice C, because 2 pi over 3 plus 2 pi, which is the same thing as 6 pi over 3, becomes 8 pi over 3. Basically, if the difference between these two things is 2 pi, then they are the same. The angles are coterminal. Number 20. So here we have h of x equals 3 to the x plus 2. My vision's not so good. And 3 to the x. So basically 3 to the x looks like that. And 3 to the x plus 2 is it shifted over to the left by 2. So what do they want to know? Which of the following is an equivalent for h of x that expresses... Oh, that's an unusual question. So this is 3 to the x, and we can turn it into this other one. This is 3 to the x. If I shift it to the left, I get 3 to the x plus 2. But it would also get to the same place if I shifted it, if I did a vertical dilation. So the way I'm looking at it is this x-intercept. For the first one, it was 0, 1. For the second one, when you put 0 in, you get 3 to the 0 plus 2, which is 3 squared, which is 9. So the answer is going to be 9 times 3 to the x. Another way to think of that is 3 to the x plus 2 could be rewritten as 3 to the x times 3 to the 2, which is the same thing as 3 to the x times 9, which is the same thing as 9 times 3 to the x. This would be a vertical dilation because it's like a coefficient in front of the thing. It accomplishes the same thing as shifting it 2 units to the left. So the answer to that one is B. 21, we have a table. It's a polynomial function. And if A is less than B, then G of A is greater than G of B. They're just saying as this gets bigger, these get smaller. So it's just decreasing. What can be true about the graph? So the function is decreasing. It's concave down because the function is decreasing. They all say that. So that's not even part of the question. But what's happening? So concave down is when it looks kind of like half of a frown. Whereas concave up It looks like half of a smile. So the question is, which of these two things is it? Well, so it's we can cross out these two because the function's not. Oh no, the function is decreasing. They all say that. We can't cross anything out. Sorry, I got confused. This question is actually pretty confusing. So the function is decreasing, and the average rate of change, over equal length, and the average rate of change over equal length input values is decreasing, increasing. What is the difference between C and D? Oh, concave up versus concave. So we don't know which one it is yet. It could be either of these situations. Let's see what happens. It goes down by 8, and this one's going down by 10. This one's going down by 12. This one's going down. It goes down by 8. Oh, it goes down by 11. No, it goes down by 10. Then 12. Then it's 14. So it went from -8 to -10. That's minus 2, minus 2, minus 2. So this first one is like is the rate of change, and this is like the rate of change of the rate of change, and it is negative. So this thing actually is concave down, but the reason why is because the average rate of change over the equal length input is decreasing. Now you could draw a little picture of this. 3, 4, 5, 6, 7. I guess it's a little tricky to draw it accurately. Minus 60. So 3 is at minus 11. And then it goes down to minus 19. See, it's going down by more each time. Yeah. So you could actually see it's part of a frown. So it is concave down. So it was either A or C, but it was C. The average rate of change over equal length. That's the definition of concave down. If the average rate of change is decreasing. So there was no way it could be A, because you can't. The definition of concave down is that the average rate of change is decreasing. So actually A could not be the answer. Okay, here's a cosine graph. The graph of f is mapped to the graph in the same xy plane by a horizontal translation. So it's moved pi over 2 units to the right. So when that happens, we just replace the x with an x minus pi over 2 in parentheses. And that is why the answer is choice B. When there's something here, say this is shifting to the right by 1/2 unit. This is shifting to the right by pi over 2 units. This is shifting down and up. So it was this question. They could have put a plus as like B, but with a plus, that would be confusing to people. But when it's a minus, it shifts it to the right. And when it's a plus, it shifts it to the left. In 23, they have a function. So you have the function C. The function C is degrees Celsius as a function of time. But then P turns temperature into kilowatts. So K, eventually it gives you kilowatts. So it represents electricity as a function of time, because the variable is still T. So there's nothing about temperature in this K function. Temperature goes in, gets changed into degrees, but that degrees gets changed into kilowatts. So there's no mention of temperature. There's nothing about temperature. And it's not time as a function. It's not like we calculate how much time there is. We put the time into the function. So it's a function of time, because T is the thing that goes in, and electricity is what comes out. 24. Terminal ray, which gives the distance of Q. So for any, what are they saying here about the 6, where's the 6, 5? The length of arc PQ is 6 units. Okay. So this is 6, the arc. And we want to know what this angle is. And this is 5. Well, there's a relationship between these three things. And it is, if this is a sector of a circle, it's the arc length, S equals R times theta. That's the relationship, if theta is in radians. So in this case, S is 6, R is 5, and theta is what we don't know. If you divide both sides by 5, you get 6/5 radians is the angle measure. Now, any point on a circle, if it was a unit circle, in a unit circle, for this angle, the point at the end of the radius there is cosine theta comma sine theta. If it's a bigger circle, it's r cosine theta comma r sine theta. So this point here is 5 cosine 6/5 comma 5 sine 6/5. And they want distance to the y-axis, which means this line, which is this length here. So it's 5 sine 6/5. Choice D. 25. So cotan is cosine over sine. Now, if I were to graph cosine, look like that, and here's another period of it. And if I were to graph sine, it would look like that. And I could make another sine curve. Now in red, I'm going to do cotan, which is cosine over sine. So when cosine is 0, which is here and here, and also here and here, cotan is also 0. But when sine is 0, this thing will be undefined because it's in the denominator. So where sine is 0, cotan is going to be undefined. And that's what they want to know, vertical asymptote. So regular cotan, we're checking if choice A is right. Regular cotan has asymptote at 0, at pi, and at 2 pi, and at negative pi, and at negative 2 pi. So it doesn't have a 3 pi over 4. I would have to shift this thing over. There's different ways to shift it over. But if I shift it over by pi over 2, that's not going to work. But if I shift it to the right by pi over 4, that's what this would be, shifting to the right. If I shift it to the right, then this asymptote would go to 5 pi over 4. But in this one, I shift it to the left, and this pi ends up at 3 pi over 4, which would be the correct answer, and that's why it is choice D. Question 26. So this is a rational function, and the numerator, it's much better if the numerator is factored. So I'm going to factor that to x minus 2, x plus 1. So that's unusual because, but there's a square down there. So well, for sure, when there's a matching factor here, that's going to be a whole at 2. But if I sort of cancel out the x plus 1 with one of these x plus 1, see the square there? I lost it. You see that square there? If you cancel this one out with one of these, you still have one here. So there's still an asymptote at -1. And that's why there's a hole at x equals 2 only, because the multiplicity is greater than the multiplicity in the numerator, and because that's the reason. That's their fancy way of saying it. They just mean the exponent. This exponent of 2 made it so that we didn't fully cancel out the x plus 1s. 27. A regression model. The residuals from the regression is plotted and labeled. So basically, you have some kind of dots, and then you have a line, and then the residuals are kind of like how far away is each point from the line. That's what all this means. And then you could plot those sometimes, like if this is like 1 unit above, 1 unit below, those become like sort of straightened out. Okay, based on the vertical axis of the residual plot, is anything shown now? Based on the point A is located... Okay, I really got to get my mind around this question because I hardly know what they're talking about yet. Based on the vertical axis of the residual plot, point A is located at 1.3. Which of the following statements is true about the model and estimates produced? So, see, the residual plot has point A at 1 point based on the vertical axis. And point B is down here, maybe? So, what this basically means is, originally, if that was the graph, this was like A, and B was like down there, those dots. So I think this means that the model gives an underestimate. It's lower than what A actually is, but an overestimate for B. I don't know. That's not the topic that I actually taught to my AP students. And finally, they have a polar equation. And they basically want you to graph it and to be mindful of the order that the points got graphed in. So I'm just going to graph this thing and see what the deal is. So a good way to graph this thing is theta r, and to plug in 0, 90, 180, 270, and 360. I use degrees, and then later on I think about radians. So if you put 0 in, you get 2 minus 4 cosine 0. You do need to know that cosine 0 is 1, so 2 minus 4 is negative 2. And for 90, cosine of 90 is 0, so this becomes 2. Cosine of 270 is also 0, so that becomes 2. Cosine of 180 is negative 1, so this becomes 6. And 0 and 360 go the same way. So at 0, that's pretty annoying. 0, it's negative 2. So this is the first point that gets graphed. At 90, 90 degrees is pointing this way. So 0, you're going this way, but it's negative. 90, it's this way, it's positive. 180 is this way, and it's 6. 270 is this way, and it's 2. And 360 is pointing... Wait, 0 is negative 2. 0 is negative 2, 360. So, pretty unusual graph. 1, 2, 3, 4, 5. Huh. That's pretty annoying. Now, I know that when you graph, let's say on an xy plane, minus 4 cosine x plus 2, it ends up looking something like this. And this has a couple of x-intercepts. So what this means is there's also going to be some points in here also. And the curve that ends up happening when all this, when you have something like this where it's like something cosine something plus something and this number is smaller than this one, we end up usually with something like that. It's called limosone with inner loop. And they want to know what this is. Well, this corresponds to this piece of the inner loop. And the question is, when does that happen? Well, notice how 1 was here and 2 was there. So I think what happened is that it went like that. So from 0 to 90, really from 0 to 45 was this little piece. And that's why, oops, that didn't work. Which of the following is the value of A and B? So they're asking for this portion, 0 to pi. Oh, it might just be 30 degrees. Yeah, I think so. Let me look at this thing again. This question is particularly confusing. Yeah, if it starts here, that's the 0. That's the 0, negative 2. So that's definitely 0 as the starting point. Pi was at 6. That's all the way out here, so it's not starting there. So it's not these two. But the only question is, how much of it is it from here to here? Oh, of course. We should try to figure out when does this thing equal 0. So let's finish this question up by finding the first spot, because you see it hits the center right here. So that's sort of where we stop. So I would do 2 minus 4 cosine theta equals 0, which becomes 4 cosine theta equals 2, or cosine theta equals 1/2. Now, cosine theta equals 1/2 at 60 degrees, which is pi over 3. That one tricked me a little bit. Earlier in this video, I made the famous chart, which is 1/2 radical 2 over 2, radical 3 over 2, radical 3 over 2, radical 2 over 2, 1/2. So it's cosine of 60, which is also pi over 3 in radians. And that is why the answer is choice A. And that does it for this video.